Okay, so here's a tweet I saw a few days ago from Stephen Storgatz. He's referencing an article in the New York Times, but it's really these two graphs that I want to show you. So he's saying a different way to chart the spread of the coronavirus. This was an article in the New York Times on clarity and insight offered by log linear plots. So this graph over here is what? Coronavirus cases in Italy and the US. So let's take a look just at that graph and tell me what you see.
Well,
So I'm zoomed in really tightly on this graph now. So what do you see here?
it seems like the US and Italy sort of start in the same area. They start really close to zero.
Mm-hmm.
The US stays closer to zero for longer, and then it begins to go upward at the very end. Italy sort of curves up from the x-axis slowly, and then it starts to go up very fast, and then the slope sort of increases very quickly.
Okay. What do you see when you look at this?
So I see that the Italy curve and the US curve are kind of the same, more or less, and the US curve is just maybe a couple of days ahead of the Italy curve.
Behind.
Yeah.
What's happening in the US is happening later.
Yeah, so we could expect maybe, the US right now is around 15,000 cases, Italy is around 45,000 cases.
Yeah, and
So
this was from a few days ago, this graph. Too,
You could expect the US graph to follow what the Italy graph is doing.
Okay. And inspecting these, they look very similar.
Mm-hmm.
And they both look like exponentials.
Yeah.
So this looks like 2 to the x or 10 to the x that we see, and they go up really fast. But now, let's see if I can do this just by sliding the computer over, a little easier. Here's the logarithm plot instead, and it gives us a little bit different way to see this when I'm plotting the logarithm. So it's going up so quickly, it's hard to tell if these two curves are the same. They look very similar.
Yeah.
But now I do the logarithm of it, and you can see that the axis on the y-axis now goes from 1 to 10 to 100 to 1,000 to 10,000 to 100,000. So it's that smushed axis that we were talking about in the last video. And now, so tell me what you see with Italy and the US here.
So Italy seems to start out very small and then jumps very, very quickly.
Uh-huh.
But it begins to slow, and the slope actually gets smaller towards the end of the graph. In the US, it sort of goes up it starts slower, and then it sort of has a constant slope for the last half of it, which was interesting, and it makes it appear that the US is actually really close to surpassing Italy in cases. It seems like eventually that this line will sort of cross Italy's line.
Yeah. All right. Great. So what do you see?
So yeah, Italy doesn't have as linear of a behavior, like it's sort of a curve up and is flattening out. So the rate in Italy is lowering, even though they're still getting more daily cases and they have more people infected, but the rate of spread seems to be leveling off, or maybe just starting to level off.
Okay.
Well, the US has more of this linear behavior, where it's multiplying by 10 like every week or so.
Yeah, or some time frame.
Yeah.
So when it's a straight line, like very much like we see in the U.S., that means we have exponential behavior.
And it even seems to be picking up at the end, like increasing.
Right. That's even scarier that you're getting above exponential behavior. And the Italy graph, which is concave down, is below exponential behavior. So from our original graphs, it's hard to see that. With the log graphs, it tells us a story that the U.S. is still experiencing exponential behavior, and Italy actually is below exponential behavior, which is some way to see that things are starting to slow down a little bit, even though it's still terrible over there. And maybe things are starting to slow down.
How did they decide to use the sort of 10 to the n scale? 1, 10, 100, 1,000. Is that the normal logarithmic.
It's just easier, probably.
Yeah, it's actually a great question. And the amazing mathematical thing is it actually doesn't matter. You could use 1, 10, 100, 1,000, 10,000. You could use 1, 2, 4, 8, 16, 32. The US would be the same line on any of those. It would just have a different slope.
Okay.
And Italy would look the same sort of concave down behavior. So that's a math, well, that's what I said before, it's sort of a math miracle. There are two common scales that you'll see on these log plots. One of them is with the tens, and the other one is with
E.
the number E. So,
Okay.
all right, so let's take a look at a different one made by someone we've seen his work before.